For 13.8 billion years, the speed of light has held a constant limit. Atoms follow the exact same rules. Gravity bends space with mathematical precision. But why? The answer might be hiding in the simulation hypothesis. Today, we're looking for the 5 clearest traces that our reality is running on a grid. Trace 1, the Goldilocks constants. Physicists call them the fundamental constants, 6 numbers etched into the fabric of reality, with no theory to explain why they are what they are. But here's the thing. If the strong nuclear force were just 0.5% weaker or stronger, stars would never forge carbon. No carbon, no life. If the fine structure constant varied by a mere 4%, ice would sink, proteins wouldn't fold, chemistry would collapse. These numbers don't look inevitable. They look selected. As if someone turned a series of dials and locked them in place, just so that the program could run. Now, you might say, that's just the anthropic principle. We live in a universe that allows life because if it didn't, we wouldn't be here to ask. And that's true, but here's the unsettling part. Even if the anthropic principle is correct, it doesn't remove the weirdness. It just tells you why you're allowed to notice it. The precision remains, a precision that, in any other context, we'd call engineering. Trace 2, the pixels of spacetime. Now zoom in, keep zooming. Atoms, nuclei, quarks, and then you hit a wall. At around 10 to the power of minus 35 meters, the neighborhood of the Planck length, our current physics stops behaving normally. It's not just hard to measure, it's like the concept of smaller stops making sense in the usual way. And that feels eerily familiar. In a video game, if you zoom in far enough, you don't get infinite detail. You hit the resolution limit. So the question isn't, is the universe pixelated? The real question is, why would a fundamentally continuous reality need a minimum unit at all? If the universe is computed, a minimum step size is not weird. It's necessary. Trace 3, the error-correcting code. This is where it gets weird. In 2012, physicist James Gates found something hidden in the equations of string theory. He found error-correcting codes, specifically a structure identical to Reed-Solomon codes. These are the exact same types of data redundancy codes used in your web browser and computer hardware to prevent data corruption. Gates didn't say he found God, but he did note that this discovery deserves a moment of reflection. Why would the deepest layer of math, the source code of the universe, need a system to fix bit flips unless the universe is processing data? Trace 4, quantum lazy loading. Quantum mechanics gives us a phenomenon that feels like cheating. When an electron isn't measured, we describe it with a spread of probabilities. When we measure it, we get a single outcome. To be clear, physicists debate what this means, but the behavior is undeniably strange. Now here's a metaphor that helps, especially if you've played open world games. Games don't fully render what you can't see. They use tricks like level of detail and culling. Distant objects are simplified. Unseen areas aren't fully simulated. Detail increases only when the camera turns toward it. The purpose of doing this is to reduce computational costs. So the simulation hypothesis interpretation is, maybe quantum probabilities are the universe's low-cost placeholder state, and measurement is the moment reality must commit, like a renderer finally resolving pixels into a finished frame. Trace 5, the universal speed limit. On a moving train, if you throw a ball forward, its speed adds to the train's. But light doesn't play by those rules. No matter how fast you're moving, light always clocks in at 300,000 kilometers per second. To enforce this, the universe bends space and time themselves. Time dilates, lengths contract, simultaneity breaks. Why go to such extremes? Maybe because every processor has a clock speed. And 300,000 kilometers per second isn't just a speed, it's the processing limit of the hardware our universe runs on. As for what happens if you try to go faster, the equations say time goes negative. You'd go back. In a real world, that feels crazy. But if the universe is a simulation, it's simple. Just try hitting rewind on your media player and see what happens to the timeline. Let's be honest, the simulation hypothesis isn't proven. Each of these traces has mainstream explanations: the anthropic principle, the limits of current theories, mathematical coincidences. But the reason this idea won't die is simple. Again and again, when we dig deep enough, reality stops looking like solid stuff and starts looking like rules, constraints, information, and updates. And that should make any curious mind pause. Because every time humanity thought it had reached the center of truth, we later discovered we were standing at the edge of something bigger. Next time, if the world is virtual, what could the ancient God mean?